Cool. All right. So if you look right here, we have the pre-final exam. So hopefully you have opened it and started going over the pre-final exam. Cause like I said, like me going over it and you going over it is completely different. Like if you want to pass the class, you're gonna need to practice on this by yourself. Cause like I said, like me going over it and you going over it, completely different. So for this one, says a laptop price at different electronics store are as follow: $899, $640, $702, $942, $950, $789. So it says using this data, calculate the following. So the following will be the mean, the variance, and standard deviation. All right, so if you look at the prompt, it doesn't say anything about showing your work or anything like that. So we're gonna jump right into ClassCal. So let's go to ClassCal. All right, so in ClassCalc, we'll say x1 is equal to a bracket. So let's enter the number. So you go 899, comma, 650, comma, 702, comma, 942, 950, 789. All right, so that's my x1. So now what I'm going to go ahead and do, I'm going to go ahead and find the mean, the variance, and standard deviation. So that should be pretty simple with ClassCal, because all you have to do, you go to the stats button. And if you look at it, we can actually just use the basic. So for the basic, we can say mean of x1. Oops, but not like that. All right, so if you look at it, I got the mean of x1, which is 822. Now let's go ahead and find the variance. So if you look right here, it says variance. So we'll say variance of x1. All right, and that's our variance. So if you look at it, it gave me two variants. One of them is for the population. One of them is for the sample. So for this one, since we know there are probably more than 6 laptops in the world, you want to go for S squared. So that's our variance. Lastly, we're going to do standard deviation. So we'll say standard deviation of x1, and that's our standard deviation. And we're all done. So any question on how I found the mean, variance, or standard deviation? All right, sweet. All right, so let me just answer the answer. So say x bar is 822, variance. Yeah, I already graded that exam. So if you go to my gray on the left-hand side, it should show you your gray. All right. Everybody good on mean, variance, and standard deviation? All right, so let me go back to my notes. All right, so if you look at it, I put my mean, I put variance, and put standard deviation. All right, so let's scroll on down. All right, so for this one, if you look at part, well, not part, but number 2 says, for the following, sketch a standard normal curve to shade the area representing the region and determine the area. So we want to sketch it, but we also want to find the area. So if you look at it, tell us this is a standard normal curve. Standard normal curve means the mean is equal to 0, standard deviation is equal to 1. So anytime you say standard normal curve, you should already know mean is equal to 0, standard deviation is equal to 1. Other hint that the mean and standard deviation is equal to 0 and 1 is that they give us a z value. Anytime they say z, pretty much they're telling us that, they're telling us that our mean and standard deviation is equal to 0 and 1. So let's go ahead and find this. All right, so if you look at it, it says z of negative 2.03. So we'll put negative 2.03 right here. And we'll put greater than. Because if you look at the arrow, it's pointing to the right-hand side. So that's why we're shading the right-hand side, because it's pointing to the right-hand side. All right, so up next, what we have to do, once you do this shader, what you want to go ahead and do is go ahead and use class calc in order to find the probability. So in class calc, what we want to do, you're going to say normal distribution. You put 0 and 1. Then, since you want to find the probability, you put CDF. And then you put the lower bound is negative 2.03. And then the upper bound will be infinity. So that's what you want to put once you get to class calc. So let's go to class calc and let's enter that. So clear, 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 clear. So we got normal distribution. All right, so we go 0, 1. We hit CDF. You put negative 2.03. We hit the magnifying glass. Wait, all right. And that's our answer. So our final answer will be 0.97882.173. Whatever decimal place you want. All right, and that's it for the last problem. Any question on how to do this last problem? All right. So let's go ahead. This. All right, so that's A. So let's do B. So if you look at B, it says the probability that 0 is greater than or equal to z, which is greater than or equal to negative 2. So once again, for this one, is in between. But you have to be careful, because if you look at 0, and if you look at negative 2, well, you should kind of know 0 is bigger than negative 2. So 0 will actually go on the right-hand side. Negative 2 go to the left-hand side, because 0 is bigger than negative 2. So since this is a number line, pretty much you put negative 2 first, and then you put 0. So then you shade in between. Any question on why we shade it in between? Right. So for this one, what I'm going to do, I'm going to show you what you have to put in class calc. But I'm not actually going to put it in class calc because you kind of have to save a little bit of time, because there's 13 pages of this. So I want to make sure that we get through everything. So you kind of know, once you get this, you want to enter into class calc. So if you haven't been practicing on class calc, practice on class calc and enter this. So once you hit CDF, this should pop up. So what you want to do, you want to put negative 2 and you want to enter 0. And then class calc will give you an answer for that one. So that's all you have to do for B. Any question for B?
Do you want me to give you the answer so you can put it?
No, that's fine. Like, let the other student get it. All right, so that's B. So let's do C. So if you look at C, it says negative 0.26 is less than or equal to Z, which is less than or equal to 1.62. So once again, let's go ahead and draw this. Just remember the middle is always 0. So we have negative 0.26. And then you have positive 1.62. So if you look at that, it's telling us that we have to shade the middle. Losing my 1.62. So this is telling us we want to shade the middle portion. So we want to find the probability that is in between those two values. So let's go ahead and let's figure out what should we put in class Cal. So in class Cal, first thing you want to go ahead and do is go to normal distribution. And make sure that you put that the mean is 0, standard deviation is 1. Then since we were trying to find the probability, hit CDF. And then this should pop up. And all you have to do is put the lower bound and the upper bound. So for the lower bound, you get negative 0.26. For the upper bound, you get 1.62. All right. So then you just punch that into class Cal. Class Cal will give you the correct answer as long as you punch it in correct. And that will be it for C. Any question for C? All right. So let's go to 3. So 3, if you look at it, so let X be a random observation that has a normal distribution with a mean of 12 and a standard deviation of 2. So it says find the area under the normal distribution curve for the following. So if you look at this one, they tell us it's a normal distribution. So whenever they tell us it's a normal distribution, that means the mean and the standard deviation is not going to be 0 and 1. So if you look at this one, they tell us the mean is 12, standard deviation is 2. So now when you go to class calc, instead of putting 0 and 1, you're going to put mean is 12, standard deviation is going to be 2. All right. Everybody good? Why the mean and standard deviation are 12 and 2? Perfect. All right, so let's do A. So for A, it's between X is equal to 7.76 and X is equal to 12. So let's go ahead and draw this out. So we have 12, which is our mean, but also if you look at it, 12 is the value that we want to find the probability for. So we go 12 right here. We have 7.76, which is over here. And since it's a between, you shade in between. All right, so that's our drawing. So that drawing should help you find out like the lower bound, the upper bound, because if you look at it, you could kind of, hopefully you could kind of clearly see the lower bound is on the left-hand side. And if you look at this, this is my upper bound because that's the highest it could possibly be and the lowest it could possibly be. All right, so let's go over and let's figure out what to put in class calc. So in class calc, first thing you're going to go ahead and do is go to normal distribution. So for my mean, instead of putting 0, we're going to put that the mean is 12. Instead of putting that standard deviation is 1, we're going to put standard deviation is equal to 2. Since we're trying to find the probability of this outcome occurring, you do want to hit CDF. Everybody good so far in that? All right. So once you go to CDF, you're going to do the lower bound and the upper bound. So the lower bound, you should be able to see that 7.76. If you look at my upper bound should just be 12. So let's go over to Class Calc and let's do this in Class Calc. So for Class Calc, you go over here, we go to stats, we go to distribution, you go to normal distribution, you hit 12, you hit 2. Then you go to CDF. Let's do that. So you go to CDF, and CDF, what you want to do, you want to press the lower bound, which is 7.76. You want to press the upper bound, which is 12. Okay. So if you look at my drawing on the right-hand side, it's kind of the same drawing that we had when we drew it out. So if you look at the probability that it's between 7.76 and 12 is 0.482999698. And that's your answer for that one. So I'll say 0.482999698. Any question on how to do it in Class Calc? All right, so that's A. So if you look right here, here go the answer. And like always, you don't have to put all the decimal places. I'll be putting it there just so I have them. But if you wanted to, you could either put like 0.48 or 0.483. Like the only answer that wouldn't be correct if you put 0.5, that's too much rounding off. So anytime you're giving me a probability, it should be at least 2 decimal places. All right, so let's do B. So for B, we're gonna do the whole thing. I'll tell you what to put in Class Calc, but I'm not gonna give you the answer because, well, you should know how to do it in Class Calc. That should be like the easy part. All right, so let's do B. So for B, if you look at it, it says between 14.48 and 16.34. So the mean is still gonna be 12. And then we have this one, which is 14.48. And this one, which is 16.34. So since it says between means the middle. All right. So that's your drawing. So from the drawing, hopefully you should be able to see that this is my lower bound. This is my upper bound. Because remember, the lower bound, the lowest value that can possibly be shaded. Upper bound is the highest value that can possibly be shaded. So now that I have the lower bound and the upper bound, let's go ahead and figure out what to put in Class Calc. So in Class Calc, you want to go to normal distribution. You still put mean as 12, standard deviation is 2, and then you press CDF. So you go 14.48, that's my lower bound. And then you put 16.34, and that's my upper bound. And that's your answer. Well, that's how you'll get the answer for part B. Any question for part B? All right, so let's finish these off. So let's do C and let's do D. All right, so if you look at this to the right of 10.02, so 10.02, since if you remember the line in the bottom follow a number line, 10.02 should be to the left of 12 because 10.02 is much smaller than 12. So you put it to the left-hand side. So then what you want to do, since it says to the right, we shade to the right. All right, so that's it for the shading. So now let's put, what should we enter in Class Calc? So in Class Calc, what we want to do first, go to normal distribution. And for this one, we're gonna put mean. Mean is still equal to 12, and we're going to put standard deviation, which is still equal to 2. So then what we wanna do, we do CDF. And for the CDF, what you wanna do, you wanna look at the lower bound. So here's my lower bound, because that's the lowest value that possibly could get shaded. My upper bound, if you look at it, we don't have a cutoff. So since it keep on going and going to the right-hand side, where you're gonna say is going to infinity. So, all right, so for my lower bound, we'll put 10.02. My upper bound will be positive infinity. So for this one, in order to get the answer, you have to put that the lower bound is 10.02, and then for the upper bound, just leave it as positive infinity. And that will be how you get the answer for part C. Any question for part C? All right, let's do part D. So for part D, it says to the left of x is equal to 9.72. So we'll go ahead and draw this again. Here go the middle, here go 12. Here go 9.72. So if you look at this to the left, so to the left is the left-hand side. So if you look at this, my lower bound is over here, my upper bound is over here. So if you look at the lower bound essentially keep going and going and going all the way to negative infinity. If you look at my upper bound get cut off at 9.72. So we're gonna do class calc. So for class calc, we're gonna just go ahead and do normal distribution. So we'll put mean of 12, standard deviation of 2. We'll choose CDF. And then we'll say our lower bound and our upper bound. So our lower bound will be negative infinity. My upper bound will be 9.72. Right, so if you enter that into class calc, that should give you the correct answer for part D. And that's it for part D. Any question for part D?
No.
All right. All right, so let's do 4. So for 4, it said the Bank of Connecticut issued Visa credit card. It is estimated that the balance on all Visa credit card issued by the Bank of Connecticut have a mean of 845 and a standard deviation of 270. Assume that the balance on all these Visa credit cards follow a normal distribution. All right, so if you look at this problem, they're telling us the mean is 846, and they're telling us the standard deviation is 270. And they're telling us this is for all Visa credit card. So since they're telling you that this is for all Visa credit card, that means we have a mean of 845, but we also have a population standard deviation of 270. So since I have mu, which is equal to 846, and sigma, which is equal to 270, this means we're using the z distribution. All right. So let's look at part A. So for part A, so what is the probability that a randomly selected Visa card issued by this bank has a balance between 1,000 and 1,400? So if you look at it, it says a randomly selected Visa card, so that means n is equal to 1. Because they want to find out that if we randomly select one card, that one card, that the balance on that card is between 1,000 and 1,400. So let's go ahead and do this. So we'll draw this out. We'll say here's 845. We'll say here's 1,000. And we'll say here's 1,400. And if you look at it, since it say between, you shade in between. Everybody good so far for this one? All right, cool. Everybody's good. All right, so we're gonna do this in class calc. So in class calc, because we have the z distribution, you want to use normal distribution. So for the normal distribution, we're gonna say the mean is 845, our standard deviation is 270. Then what we're gonna go ahead and do, we're gonna say CDF. And if you look at it, this is my lower bound. This is my upper bound. So for my lower bound, we're gonna say lower bound is 1,000. My upper bound, 1,400. Any question for 1,000, 1,400?
When it gives you the normal distribution, like the standard and the mean, that's when you use it, right? And you only use 1, 0, and 1 when they don't?
Yeah, well, you use 0 and 1 when they give you the z value. Because if you look at this one, they told me z between negative 0.26 and 1.62, or they tell me z between -2 and 0. But if you look at number 2, the reason why we know it's 0 and 1 because it gave us a z value.
Okay, got it. Thank you.
Cool. Yeah. All right, so let's go ahead and let's go to class calc to enter this. All right. So once again, class calc, we go to stats. You want to go to distribution, and we do a normal distribution. So for the normal distribution, you want to say mean is 845. You want to say sigma is 270. And then what you want to go ahead and do is do CDF. If you want to get the picture of it, you can do that. So if you look at the lower bound is 1,000. My upper bound is 1,400. So if you look at the probability, it gave me 0.263. There you go, 0.263. And that's what you want to do for part A. Any question in regard to what I enter into part A or enter into class calc?
No.
All right. All right, so that's part A. So let's do part B. All right, so let's do B. So it says, what percentage of Visa card issued by the bank have a balance of at least 750 points? Oh, $750, sorry, not points. All right, so what we could do, I could jack this. Copy. All right, so if you look at it, it wanted to be at least 750. So me are having a hard time for at least. You kind of have to just remember at least mean that's the minimum, but it could be higher than that. Because if they tell you at least 750, they're telling you it could be 750, but it could be any number bigger than 750. So if you are having trouble with that, you might want to put that in like on a note card or something like that. So that way, when something like that does show up, like you know how to solve for it. So we shade the right hand side because it says at least. All right, so let's go to class calc. All right, so in class calc, what you want to do, since this is a z distribution, you do normal distribution. Then what you want to do, you want to do a mean of 845. What's my standard deviation? I forgot, so let me look it up, 270. All right, so remember, since we're trying to find the probability, the reason why I know we're trying to find the probability says what percent. So that's telling me we want to find the probability. You want to hit CDF. So then you go, your lower bound is 750. Your upper bound is positive infinity. So that's what you want to enter into ClassCal. Once you enter that into ClassCal, it should give you the correct answer, and then you go from there. So that's how you want to do part B. So you have to just be able to interpret when it says at least 750 means 750 or above. But any question in regard to B? All right. All right, so let's do 5. So for 5, it says if a bag contains 5 white ball, 6 red ball, 9 black ball, determine the probability of pulling out. All right. So for this one, what we want to, part A, is find out what's the probability that we get a black or a white ball. So we want to find the probability that we get a black or a white ball. So for this one, if you kind of think about, like, if I'm just selecting one ball, it's not possible for that ball to be a black ball and a white ball. So the two events are mutually exclusive. Okay, we're either gonna get a white ball or we're gonna get a black ball. But it's kind of impossible if I'm just selecting one ball, that ball will be a black and a white ball. So they're mutually exclusive. So since they're mutually exclusive, we'll say probability of black, and we'll add that to the probability of white. So for the probability of black, if you look at it, they say there's 9 black balls. So if I want to find out how many total balls do we have, you want to do 5 plus 6 plus 9, and you get 20. So there's a total of 20 balls. Cool. So we do 9 divided by 20, and then we add that to the probability that the ball is white. So the probability that the ball is white is 5 out of 20. So if you do 9 over 20 plus 5 over 20, you get 14 over 20. Let me do that. So if you do 14 divided by 20, cool, you get 0.70. All right. And that'll be it for A. Any question in regard to A? All right. So for part B, if you look at it, you want to find the probability of pulling a white ball. So if you want to find the probability of pulling a white ball, you go 5 divided by 20. 5 divided by 20 is 1 over 4, which is 0.25. And that's it for B. So for B, you should have gotten 0.25. Any question for B? All right, so let's do C. So it says a white ball and then a black ball without replacement, with replacement. All right, so for this one, what we want to do, if you kind of remember when we did the multiplication rule, we want to use that for part C. So for this one, we want to find the probability we get a white ball, and then we get a black ball. So we're gonna do this without replacement. So when it says without replacement means once you select that object, you can essentially put that object back. So once I select the white ball, pretty much I can't put that white ball back into the bag. It essentially stayed outside. So for this one, if I want to find the probability of getting a white ball, well, we already found that to be 5 over 20. But since we're doing this without replacement, that means now instead of having 20 balls, you only have 19 balls. So you put 19 in the bottom. So now we want the second ball to be black. And if you remember the probability, or we have 9 black balls. So you go 9 divided by 19. So then what you want to go ahead and do, you want to go ahead and just find that out. There you go. 5 divided by 20, multiply it by 9 divided by 19. So that's 0.1184. And that'll be it in regard to that one. Any question for that first part? All
So
right.
you multiply it?
Yeah, so you multiply. Because if you have parentheses means that you multiply it. All right, so now we're going to do width replacement. So width replacement means once I select the ball, you essentially put back the ball and you can reselect that ball again. So we're once again going to find the probability of white and black. So for this one, the probability that you get a white ball will be 5 out of 20. But in this case, since we're putting back that white ball back into the bag, that means I could actually reselect that white ball. So in this case scenario, we still have 20 balls in whatever the bag or whatever we have it in. And for the probability we get a black ball will be 9 out of 20. So then we do 5 out of 20, multiply by 9 out of 20, and that should be our answer. So for this one, you get 0.1125. And that will be your answer for C. So width replacement means once you get the object, you put back the object. If it's without replacement means once you get that object, you essentially take it out and you can't reselect that object again. But that's it for C. Any question for C? All right. So let's do this one. So it says, assume that the weight of all packages of a certain brand of cookie are normally distributed with a mean of 32 ounces and a standard deviation of 0.3 ounces. Determine the probability that the mean weight of a random sample 20 packages of this brand of cookie will be, and then you have to do all of those. All right, so first thing you have to kind of just read the problem. And if you read the problem, they give us 32 ounces and 0.3 ounces. So 32 ounces, that corresponds to your population mean. Because if you look at the 32 ounces, they tell us that's our mean, but they don't tell us that they did it from a sample of 20 or 30 or 100 or 500 or whatever it was. They pretty much just tell us that the mean weight is 32 ounces of this certain brand of cookie. And then if you look right next to it, they gave us 0.3, and that's our standard deviation of the population. All right. So we got mu is equal to 32, we got sigma is equal to 0.3. Any question on how we got mu or sigma? All right. Also, if you look at the problem, they tell us we took a sample, and they tell us we took a sample of 20. So that's very important because that means we have to adjust our standard deviation. So the standard deviation, that's the standard deviation if we're randomly selecting one object or one package. But since we're randomly selecting 20 package, that means we're gonna have to adjust that. So we'll adjust that once we go to part A. All right, but any questions so far for the labeling for mu, sigma, or n?
No.
All right. So let's go ahead and do this next problem. So let's do A. So for A, we have 32 in the middle. You put 31 on the left of that, and then you put 33 to the right of that. And then you shade in the middle because it says between. So for this one, if you look at it, since we have sigma, which is the population standard deviation, we're still using normal distribution. But the thing is, we have to give it our mean. So our mean is 32, and we have to give it the standard deviation. So for standard deviation, you have to be careful because we can't put standard deviation at 0.3 because that would give us a wrong answer. Because we have to find sigma of x bar, which is 0.3 divided by square root of 20. So we have to do 0.3 divided by square root of 0.20. So if you do 0.3 divided by square root of 20, you should get 0.067. 0.067. And you put this in for over here. So anytime you're doing it for a sample size greater than 1, you always have to adjust your standard deviation. So for this one, since standard deviation at x bar is equal to 0.3 divided by square root of 20, you have to put 0.067. All right. Any question in regard to that? All right. So once again, since we're finding the probability, you want to use CDF. So for CDF, what you want to make sure that you enter, you want to say what's your lower bound and what's your upper bound. So my lower bound is 31. My upper bound is 33. So now I'm going to go ahead and switch over to ClassCalc, and I'm going to get the answer for that. So you go to stats, you go to distribution, you go to normal distribution, you go mean is 32, you go standard deviation is 0.067, and we go to CDF. So for CDF, what you want to go ahead and do, you want to go ahead and put the lower bound is 31, my upper bound is going to be 33. I think we broke ClassCalc.
I got the same thing.
Yeah. All right, so you put 1 or 100%. Cool. And that's it for ClassCalc. Any question on how to put it on ClassCalc? All right, so let's go back to my notes. All right, so if you look at part B says at most 30 ounces. So at most 30 ounces. So right here, 32. Here you go, 30. If it says at most means that's the max. So that means telling the max it could be 30. So it could be 30 or anything below 30. So you want to shade everything to the left-hand side. All right. So then once you do that, what you want to do, go to ClassCalc. So in ClassCalc, we're going to say normal distribution. You say 32 is your mean. You say 0.067. That's your standard deviation of the sample of 20. And then what you want to say CDF. You want to put the lower bound and the upper bound. So for this one, the lower bound, since it keeps going and going and going to the left-hand side, it goes to negative infinity. And then for the upper bound, you want to put 30. Any question on how we got the lower bound or the upper bound? All right. So we go back to ClassCalc. So in ClassCalc, since we already have the mean and standard deviation there, you're going to change this. So just leave it blank. And then you change it from 33, we'll change it to 30. All right, so if you look at ClassCalc, it says 0. There's 0% chance of that happening. Right. And that's it for B. Right. Any question for B? All right. So let's go ahead and let's move on. All right, so let's do number 7. So it says, suppose there are 106 body temperature having a mean of 98.20 degrees Fahrenheit. Assume that the sample is a simple random sample and a population standard deviation sigma is known to be 0.62 degrees Fahrenheit. Use a 0.05 significant level to test the common belief that the mean body temperature of healthy adult is equal to 98.6. All right. So if you look at this one, they wanted to test something. Like the reason why I know they wanted to test something. Well, if you look right here, it says test the common belief. So it says test the common belief, but also like other good clue that telling us that we had to test. They gave us a significant level. Like anytime they give us a significant level, like we know we're gonna have to test it out. So yeah. All right, so let's go ahead and do this. So if you look at it, they gave us a population standard deviation. They told us population standard deviation is equal to 0.62. So they gave us a population standard deviation. So we know for this one, since we're doing a hypothesis test, if you remember, there's two options for a hypothesis test. There's a t-test and then there's a z-test. So for this one, since we have population standard deviation, this is gonna be a z-test. Remember, the reason why we use a t-test if we have a sample standard deviation. All right, so I know sigma is equal to 0.62. If you look at my n is 106. And if you look at it, we get x bar to be 98.20. And lastly, we get mu is equal to 98.6, because this is their claim. They're claiming that the body temperature of a healthy adult should be equal to 98.6. Because if you ever go to the doctor, they always tell you that the mean, well, your temperature should be somewhere around 98.6. All right. Everybody go for the labeling. Also, you want to be careful because for some of you, like in the test, you mislabel a bunch of stuff, and that's why you got some of the problem incorrect because you said like the sample was my mean and your mean was your sample. So you want to be careful on labeling this because if you mislabel it, pretty much your whole problem is going to be incorrect. So you might want to take some time, just read problem and you try and see like if you could label them. So go back to past lecture and you see, just read the problem and just try to see if you could label like what is the mean, what is the sample size. Because for some of you, you did have that issue on doing that. All right, so let's do the null and alternate hypothesis. So for the null hypothesis, here, I think it stopped sharing. So let's stop share. Let's reshare. Oh, don't want to share that. Well, let's do that. Let's do stop share. Share that. All right, so Okay, let's try this. Let's try sharing this one more time. Share. Download. There we go. So yeah, so just be careful when you're labeling stuff because like I said, like if you mislabel anything, pretty much your whole problem gonna be incorrect. All right, so the null hypothesis. So if you look at the null hypothesis should be your mu. So our claim is that should equal to 98.7.6. So we say mu is equal to 98.6. All right. And then if you look at the alternate hypothesis, you will once again put mu, you'll once again put 98.6. But if you read the problem really doesn't give us any inclination on what the mean should be. They don't tell us if they think it should be greater than 98.6 or if they think it should be less than 98.6. So anytime they give you that, what you have to do is just say not equal to. Because since they're not giving us that they think it should be greater than 98.6 or less than 98.6, you say that's not equal to 98.6. So that's what we're trying to prove. We're trying to prove that it's not equal to 98.6. Any question on why we choose 98.6 or not equal to 98.6? All right, let's get to the problem then. So looking for us for this problem, now we're gonna go over it. We're gonna go over to class count. So let's go over to class count. So where is class count? All right, that's not class calc. So for this one, we're not going to use the normal distribution or t-distribution. Anytime you're doing a hypothesis test, what you want to do, you want to go over where it says test. So you go to test. And if you remember, I told you we have two options. You can either do a z-test or a t-test. Z-test if you have sigma. So if they give you population standard deviation, you use a z-test. If they tell us that we don't have a population standard deviation and we only have a sample standard deviation, you use a t-test. In this case, we're going to use a t-test, a z-test, sorry. So for the z-test, we're going to say mu. Mu is 98.6. Oops, put a comma, 98.6. If you look at sigma, we're going to say this is 0.62. Then we're going to put our sample mean. Our sample mean was 98.2. And lastly, our sample size was 106. All right. Any question on so far what I answered for the z-test? Okay. So if you look at our z value, this is our z value is negative 6.64. If you look at the p value, pretty much it's telling us is 0. So it's telling us it's not significant. So let me write that down for the notes. So we're going to say z is equal to negative 6.64. And we get p-value, which is pretty much 0. All right, so let's go back to my iPad. All right. So if you look at, I got a z value is equal to negative 6.64. I got p value is equal to 0. So if you look at p value, you always compare p value to your alpha. Alpha in this case scenario is 0.05. So if you look at alpha, which is 0.05, if you look at p value, which is 0, alpha is clearly bigger than p value. Since alpha is clearly bigger than p value, you put reject HO. So for this one, we reject the null hypothesis. So since we reject the null hypothesis, now what we have to do, we have to make a conclusion. So for the conclusion, anytime you reject the null hypothesis, you always have to say there's enough evidence for the alternate hypothesis. So you say, there is enough evidence to support that. So that's what we'll put. We'll say there is enough evidence to support the mean that the mean temperature of an adult is not 98.6 degrees Fahrenheit. And that's it for that problem. So anytime they ask you to test a claim, that's what I'm expecting. I'm expecting you to do the null alternate hypothesis. I'm expecting you to give me the z value, the p value, tell me if you should reject or if you should fail to reject. And lastly, for you to tell me if there's enough evidence to support it or if there's not enough evidence. All right, but that's it for that last problem. Any question for that last problem? All right. So for this one says a study conducted a few years ago claimed that the adult males spend on average of 11 hours a week watching sports on television. A recent sample of 100 adult males showed that the mean time they spend per week watching sports on television is 9.5 hours, with a standard deviation of 2.2 hours. Test at a 5% significant level if currently all adult males spend less than 11 hours watching television, sports on television. All right, so the first thing you always want to do, just label everything. So mu is equal to 11, n is equal to 100. But if you look at the 100, the 9.5 is coming from the 100 and the 2.2 is coming from the 100. So both of these information are coming from the 100. So that means both of them are sample. So that means we have a sample mean of 9.5. We also have a sample standard deviation of 2.2. So you do have to be careful with that, because now that this is a sample standard deviation, not a population standard deviation, this is a t-distribution. Any question on how I figure out that S, well, the sample standard deviation versus the population standard deviation? All right, so let's go ahead and do the null and alternate hypothesis. So for the null hypothesis will say HO of mu is equal to 11. My alternate hypothesis will be mu is less than 11. So if you look at it, we want to prove that they spend less than 11 hours watching sports on television. So that's my null, that's my alternate hypothesis. Any question for my null, my alternate hypothesis? All right, up next, what we're gonna go ahead and do, we're gonna go ahead and do this part in class calc. So in class calc, let's go ahead and enter this. So remember, for this one, instead of using the z-test, we're gonna use the t-test. So let me take away this. So we go to stats, we go to tests, and we go to a t-test. So for t, if you look at it, say 11 for my mean, 100 for my sample size. Oops, doesn't want sample size, want sample mean. Sample mean is 9.5. If you look at it, want S is 2.2. And lastly, I want sample size of 100. Yeah. All right, so if you look at class calc, it gave me the t-value. The t-value it gave me is negative 6.82. If you look at the p-value, since we said that the alternative hypothesis is less than, you want to use the symbol that says less than. So if you look at it, it says p-value is equal to 0. All right. Any question? I got the t-value or the p-value. Sweet. All right, so let's go back to my notes. All right, so if you look at the p-value, since the p-value is 0, that should kind of tell you that alpha, no matter what alpha is, should be bigger. And also, look right here. Here go alpha. Alpha is 5%. So you go 0.05. So 0.05 is greater than p-value. So we say reject HO. So since we reject HO, you want to say there is enough evidence to support, and then dot, 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 whatever we're trying to support. But that's it for that last problem. Any question for that last problem?
No.
All right. Let's go on to number 9. So for number 9, if you look at it, it says economists want to estimate the mean income for the first year of work for college graduate who had the profound wisdom to take a statistics course. How many such income must be found if we want to be 95% confident that the sample mean is within 500 of the true population mean? Assume that a previous study had revealed that for such income, sigma is equal to 6,250. All right, so for this one, do you want to know the sample size? So to find the sample size, you have to use this formula, z times sigma divided by margin of error squared. So that's the formula that we want to use. So if you look at this one, they already gave us sigma, which is 6,250. And they already gave us the margin of error because they want it to be within 500. So you divide this by 500. The only thing that we need is a z value. So if you go back to the lesson plan or the lecture that I gave you for confidence level for the z value, if you remember, we already had like a pre-noted like for some of them. So like if we had 90% confidence level, our z was 1.282. If we had a 95% confidence level, it was 1.96. So you put 1.96 here and we square. So in order to find the answer for this one, we're going to do 1.96 times 6,250 and then divide it by 500, and then you square that whole thing. Any questions so far for this formula? All right, so I'm going to work this out on my calculator. So 1.96 times 6,250 divided by 500, and we square. So if you do this in your calculator, you should get 600.25. But remember, since this is the sample size, we always round it up, and we round it up to 601. So that's your answer for 9. Any question for 9? All right, so for this one, says the article US Today state that internal survey paid by directory assistant providers show that even the most accurate company give out wrong number 50% of the time. Assume that you are testing such a provider by making 10 requests, and also assume that the provider gives the wrong telephone number 15% of the time. So for this one, we're requesting 10 phone numbers. So that's your N. And the probability that they're wrong is 0.15. So for this one, since we have a set amount of trial, and since we know the probability of success, which is 0.15, this is a binomial distribution. So anytime they give you an N and they give you the probability of making, or the probability of success, that's a binomial distribution. So for this one, we're gonna have to use binomial distribution. So if you look at part A, it says determine the probability of getting one wrong answer. So since we only want to get one wrong answer, that means X is equal to 1. So we have to find the probability that X is equal to 1. So we're going to use the binomial distribution. So I'm going to go over to COST-Calc right now and use the binomial distribution. So let's go here. So let's go to stats. Let's go to distribution, and let's go over to binomial distribution. So for binomial, we'll put N, which is 10. We'll put P, which is 0.15. And if you look at this one, we're going to say PDF because we want the probability to be exactly 1. So we put 1. All right, and we're done. So we get 0.3474. And that will be it for part A. Any question in regard to part A? All right, so let's do part B. So for part B, it's determine the probability of getting at most one wrong number. So at most means that's the maximum amount of wrong number I get. So for this one, you want to find the probability that X is equal to 0 and X is equal to 1. So to find the probability that X is equal to 0 and X is equal to 1, what we have to do, we're going to use CDF. So we'll put the lowest is 0, we'll put the highest is 1. And if you want to see the drawing, press draw. And you get 0.544. So you get 0.544. And that's the probability of getting at most one wrong, because at most one wrong means 1 is the maximum, but you could get also 0 wrong. Right. Any question for B? All right. So let's do C. So if you look at C, it says determine the probability of getting 3 wrong numbers. So for C, we want to find the probability that X is equal to 3. So all we have to do, instead of saying CDF, we want to use PDF because we want it to be exactly 3. So you hit 3 right here, and that's your answer, 0.1298. And that's it for problem number 10. So let me switch over for that way you can see the answer as I put it in All right. So those are your answers. So for part A, since we want it to be exactly 1, you should get 0.3474. For B, to get the probability of 0 and 1, it will be 0.544. And lastly, to get the probability of getting 3 wrong number, it will be 0.1298. So that's it for that one. Any question for the last problem? All right. So let's do 11. So for 11, it says a consumer agency that process that lawyer rate are too high wanted to estimate the mean hourly rate for all lawyer in New York City. A sample of 70 lawyer taken from the New York City show that the mean hourly rate charged by them is 230, and a standard deviation of hourly charge of all lawyer is 55. All right, so we get sample mean of 230, 223. And then if you look at it, it said the standard deviation of all lawyer is 55. So that means this is sigma. So once again, you have to be careful because they are giving you information for this because it's telling you the sample of 70 has a sample mean of 223, but then they tell you the standard deviation of all lawyer is 55. So we say X bar is equal to 223, we put sigma is equal to 55. So lastly, what we're gonna do, we have to get the sample size. Sample size is 70 lawyers. All right, any questions so far? I got sigma, X bar, or N. All righty. So if you look at part A, it says constructing 99% confidence interval and a 90% confidence interval. So for this one, it should be pretty simple because we're just gonna use our Z interval. And we're gonna use the Z interval in class count. So let's go over to class count. So right here, we'll X out this. So we go to stats, we'll go to test, and we'll do a Z interval. There we go. So we put sigma, which is 55. We put X bar, which is 223. We put N, where N is 70. And lastly, we'll put sigma, which is, or sorry, we put confidence level, which we'll do is 0.90. So if you look at 90% confidence level, we get 212.19 all the way to 233.81. So that's the confidence interval for a 90% confidence interval. But if you look at it, they want us to do for 90 and also for 99%. So while I'm here, I'm gonna also do it for 99%. So for 99%, we 206.07, and we get 239.93. And if you actually look at part A, they want you to find the margin of error. So for the margin of error for 99%, we got the margin of error to be 16.93. And for 90%, margin of error is equal to 10.81. But that's it for A and that's it for B. So for this one, you can just do it all with class calc and it should give you the right answer. All right, so that's your A. So if you look at A, I have my 2 confidence interval, and if you look at B, I have my 2 margin of error. All right, but any question in regard to A or B? All right, so let's go ahead and do this one. All right, so for this one, we're not going to do B, but we are going to do A. So it says determine T given the following condition. So it says sample size of 20 and confidence level of 95. So we want to find T alpha divided by 2. So in order to find T alpha divided by 2, you're going to need two things. Well, the first thing what you want to go ahead and do, you need to find degrees of freedom. The degrees of freedom is 19. Because if you remember how to calculate degrees of freedom, you do n minus 1. N minus 1 will be 20 minus 1, which is 19. Then what you want to do, you want to use the confidence level to find alpha divided by 2. So first find alpha. Alpha is 1 minus 0.95, which is equal to 0.05. Then you do alpha divided by 2, and you get 0.05 divided by 2, and you get 0.025. So now in class calc, we're going to tell it we have a degree of freedom of 19, and we have alpha divided by 2 of 0.025. Any question I got degrees of freedom or 0.025? All right. So let's go over here. So to do this, we're gonna go to stats, we're gonna go to distribution, we're gonna go T distribution. So the first thing it asks me degrees of freedom is 19. So the next thing what we wanna do, we wanna find the inverse. So you do inverse CDF and you do 0.025. So once you do that, we get T star is equal to 2.093. And that's your final answer in regard to A. Any question for A? Cool. All right. And then B and C, you can just skip it. Because we didn't go over that. So don't worry about that for the test. All right, so let's do 13. So for 13, if you look at it, it says researcher measured the percent body fat and the preferred amount of salt for several children. Here are the data for 7 children. So the preferred amount of salt is on the left-hand side. The percent of body fat is on the right-hand side. So if you look at this, they're giving us 2 data sets. So what you want to do, you want to put this in your table in class calc. So let's go ahead and enter this into our table in class calc. So we put the plus button, and if you look at that table pop up, so we put table. So we say 0.2, 0.3, oops, 0.3, 0.4, 0.5, 0.6, 0.8, and 1.1. All right, so that's my X. Now we're gonna put our Y. So we say 20, 30, 22, 30, oops, 38, 23, and 30. So just remember, before you do anything, just make sure all of the numbers are correct. So you kind of look over them again. 30, 38. Cool. All right. So if you look at part A says determine the correlation coefficient. So if we just want to find the correlation coefficient, what we could do, let's go to stats, and you want to go to, I believe, advanced. And if you go to advanced, since we're trying to do a linear regression, just go right here where it says linear regression. So linear regression, if you look at in the first list is X1, so you put X1. If you look at the second list is Y1, so you put Y1. All right, so if you look at the R value, because R is the correlation coefficient. So right here we have the correlation coefficient of R is equal to 0.2976. All right, and that's it for A, because A, that's the only thing it's asking for. Just find the R value. So now, if you look at B, it says determine the regression equation. So to determine the regression equation, is this over here. Because if you look right above R, it says equation and give me y hat. So that's the equation that you want. So we say y hat is equal to 6.01485 x plus 24.22, blah, 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 blah. All right, so that's how you want to use class count. So if I'm asking you for the R and the linear regression, all you have to do is go to stats, go to advanced, and make sure that you choose linreg. All right, any question for that? All right, so let me show you where to go. Well, let me show you the answer. No. All right. So if you look at the R value, I put R is equal to 0.2976. If you look at the linear regression, that's my linear regression. And that's it. Any question in regard to either A or B? Sweet. All right, so we're all done with this practice review. So let me show you where tomorrow tests are going to be at. So that way you know where to go. All right, so to go to tomorrow test, you go to Math 132 Summer 2020. You click on it. Blah, blah, blah. And then you just pretty much go all the way down to the bottom. And you go right here where it says final exam. So here go the pre-final exam. That's what we just went over. So this is what's going to be opening up tomorrow. So tomorrow, this is actually going to open up tomorrow. They're going to be opening up tomorrow at 10 a.m. Let's see. Cool. So it's going to open up at 10 a.m. and then it's going to close at 4 p.m. So for this one, you're going to have a 6-hour period to do it. And for this one, you're going to have 90 minutes to be able to do the exam. So once you start the exam, so if you start the exam at 10 a.m., you're going to have 90 minutes from 10 a.m. in order to submit the exam. And that's the only thing you have to do tomorrow. So yes, do the exam and all the activity, you should have already turned that into Blackboard, and the homework, well, that should have been completed already on Blackboard also. So the only thing you have to worry about is doing the exam. And also, just remember today you do have a SI workshop with Erica today. So do go there because pretty much today is the last workshop of the semester. And just also remember the workshop is for credit. So it's easy point just for attending workshop and just going to workshop. And also, Erica, if you can, once you finish taking the row for your workshop, can you send me the list for that way I can start calculating the 5%?
Yeah, I can do that.
Cool, thank you, Erica.
Mhm.
All right, any question before I close on this meeting?
Will you be posting today's the study guide?
Yeah, I'll post it up on, if you go to content, you just go to week 6 and then you go week 6 annotation.
Okay, thank you.
Yeah. All right. Any other questions?
How many questions are going to be on the test tomorrow?
I don't know if I could look it up. 11 questions.
Okay, thank you.
You said that you haven't finished the activities, right? Grading them?
Yeah, correct. Yeah, because I only did like up to 14.
Okay.
Yeah. All right. Any other questions? All right, cool. So I'm gonna close this out, and then that's it for today. Later, guys.